أعوذ بالله الشيطان الرجيم بسم الله الرحمن الرحيم الحمد لله رب العالمين الصلاة والسلام على أشرف الأنبياء والمرسلين سيدنا محمد وعلى آله وصحبه أجمعين. Assalamu alaikum warahmatullahi wabarakatuh. First of all, I would like to thank the organizers for giving me the opportunity to present my yet to complete paper. So the title that I have chosen to present in this conference is as written there, Elements of Mathematization in Kalam, a preliminary survey of selected works. Of course, when I was formulating this title, it was a bit over-ambitious. I mean, a survey of selected works presupposes that you have read like all the major works and select from them those elements. But as I work on this paper, I realized my limitation that I can only I only refer to Al-Iqtisad fil I'tiqad of Al-Ghazali, and I can only discuss very few examples, but we will explain later. The motivation, amongst the motivation for me to discuss this topic is basically one of our keynote speakers' book, Professor Basil At-Ta'i. He basically when he first came to Malaysia last year or last 2 years, I was very excited because he proposed something to me, something very new that I have not encountered any one who proposed before. Basically, he's a physicist, cosmologist, a theoretical physicist, and we know that amongst the frontier of modern physics is still these two theories, quantum mechanics and special and general relativity. I mean, until now we have not, although these two theories have developed tremendously, and we have not achieved any breakthrough of the same magnitude of these at the same magnitude of these two theories. And these two theories require interpretation because its results, its theories are so bizarre, it's so unusual to the common understanding of especially those who come from the classical physics background. And because it challenges us to the way we see reality. We can say physical reality, but at the level of atomic and subatomic particles, and at the huge scales of space and time, the boundaries between what is physical and what is perhaps considered to be metaphysical has become blurred. We don't really, perhaps for instance, when the atom itself or subatomic particle, I mean, are they really a physical existence, or are they mathematical constructs indicating something that exists? Because we do not observe them directly, we only observe its effects, and we create mathematical models out of it. So, and the mathematical models that we produce in describing their behavior is something that to a classically minded person will be something bizarre and require interpretation. And there are more than a dozen interpretations. The most prominent interpretation is the Copenhagen interpretation, and I remember last time in IIUM I attended Prof. Basil's talk, and I asked him a question, and I betrayed this Copenhagen interpretation because it came so naturally, because that's how I studied it. And Prof. Basil just say, what's collapsing? What do you mean? So I was caught because he has another interpretation. He's proposing, in fact, a new interpretation derived from the tradition of the science of Kalam. And I've read the book a few times, at least 2 times from cover to cover, and several more times just focusing on some chapters. And to me, this is if I were to pinpoint what from a mathematics and physics perspective, when the most interesting part is this part, that he actually gave two postulates or two truth claims that came from the science of Kalam to interpret modern physics, quantum theory in particular. Of course, it is at this stage it is still raw. It is not yet refined, but the author of the book is here, so I'm discussing about your book, Prof. Basil.
Yeah, thank you.
But earlier, 2 days ago, when he in his keynote, he mentioned something very interesting as well to explain the phenomena of the double slit experiment. That when he made an analogy with the frequency of creation and recreation with the blinking of the eye, so that it cannot distinguishes that. So this is, to me, this is something very profound and new, and it is most meaningful because it came from the science of Kalam, and it engages directly modern physics, and it has the potential to be developed into real theory, physics theory, and that gives about real results. In another chapter in that book, he quoted Paul Davies, and there is evidently a crucial concordance between, on one hand, the laws of physics, on the other hand, the computability of the mathematical functions that describe those same laws. This is the question: why nature exhibits the mathematical characteristics? Okay, before that. And this is my interest in all this is precisely this, because we can see mathematics as just purely a rational construct to describe physical phenomena, or in the Kantian category, I mean, he called it the a priori synthetic a priori judgment of the possibility of mathematics, so that you have a domain of mathematics, and there's a natural phenomena or laws of nature, according to Dr. Basil, and then the mathematical aspect of that laws of nature or natural phenomena is physics. However, in the what's interesting about modern science or modern physics is that the role of mathematics is not only descriptive. I don't think it is merely we observe phenomena and we construct our rational construct in mathematical formulation to describe the phenomena, but in the history of physics in the last 100 years, we have made discoveries through mathematics. I mean, it's also somewhat prescriptive. I mean, from your mathematical formulation, we deduce theories about nature, and later on verify it through experiment. So that intrigues some physicists, particularly perhaps we can mention Eugene Wigner. He wrote that famous paper, the unnatural effectiveness of mathematics in natural sciences, unreasonable effectiveness of mathematics in natural sciences. But so the domain of physics has expanded. I mean, it's not just a mathematical construct, but through mathematics you derive, we deduce also newer insights into the nature of physical reality. So this is just a rough intuitive Venn diagram just to capture what I meant. So it might expand to include some perhaps non-mathematical aspects of natural phenomena, and at the same time it also expands. It includes the pure mathematical. The pure mathematics becomes physics, but it could also expand in this way. I mean, it may cover even the not mathematics and non-natural. I mean, because we don't have real clear demarcation between what's physical and what's metaphysical. In the past, it has been sublunar is the physical, the beyond the moon are all metaphysical. But that is no longer the case. Now, during the time of I forgot to mention the Pierre Duhem. He was a physicist. He wrote extensively about on the history of science. During his time in the late 19th, early 20th century, during his time, the atom itself is controversial. I mean, they don't really. Some physicists believe in the existence of atoms, some don't. And when Duhem decided to believe in the existence of the physical atom, to him it's a mathematical entity. It's a it does not exist, but it's just mathematics. It's just an object of the mind, or in the scale of maratibul wujud, perhaps wujud dhihni. Its existence is only in the mind. It's not a physical.
Excuse me a second.
Okay.
If you can remove this circle in the middle,
Yeah.
and try to make the overlap larger. Remove the circle in the middle
Mm-hmm.
and make the intersection between mathematics and nature larger. That's what you are going to say.
That was the previous one. Yeah.
You can
yeah.
remove this circle.
Yeah. But this one.
Increase the amount or the area of the intersection
Yeah.
by bringing both nearer.
This one is increase the amount of intersection. This one is the possibility that it goes beyond even the two. Yeah.
What I said remains to be valid.
All right. Okay.
What I said in the book remains to be valid.
All right. Okay. Yeah, this is Duhem, the person I just mentioned, and he in the book to save phenomena. I mean, it's a translated work from French. He pointed out to the historical origin of the idea, the process of mathematization. He mentioned in the book, which is basically a translation from Simplicius' commentary. Plato lays down the principle that heavenly bodies' motion is circular, uniform, and constantly regular. Thereupon, he sets the mathematicians, or the geometers at that point, the following problem. What circular motions, uniform and perfectly regular, are to be admitted as hypotheses so that it might be possible to save the appearances presented by the planets? So the history of astronomy is where we look at when it comes to this period of time. And therefore, you have concentric circles, whether geocentric or heliocentric, and you construct epicycles just to preserve what you observe. Because when we observe, it's not exactly circular, so you have to modify things a bit. You have to introduce equants and deference and etc. And so the point is that circular and saving the appearances. Okay, now because my topic is about mathematization, I'm not going to discuss much about the historical aspect, but the circular. How do they define circle? So what is mathematization? Okay, let's look at that circular. What is a circle? I mean, perhaps the definition goes further back, but we can point to Euclid, who wrote the Elements, where he defined a circle as a plane figure contained by one line, such that all the straight lines falling upon it. By line, he does not necessarily mean straight, according to Euclid. Upon it, from one point, among those lying within the figure are equal to one another. Or equivalently, if you want to put it in a modern way of putting things, a closed planar curve that is equidistant to a fixed point. That is basically a circle. Even without this definition, I mean, everybody understands what a circle is. But sometimes when you want to work on a theory, you want precise definitions, you start giving definitions like this. So that it rejects anything that is not circle, and it just includes exactly what is circle. And then we fast forward, we cannot go all the details, historical details. We fast forward to Descartes because these are amongst the major milestones. So Descartes introduced the system of coordinates. So now circle becomes a set of points following that formula. And, sorry to talk about mathematics at 4 p.m., but that's those who, well, anyone who has some background in high school mathematics would recognize that that is a formula of a circle in the Cartesian coordinate. The center would be the coordinate AB, the radius would be R. So it becomes like the set of points. We fast forward to modern pure mathematics. So this is a definition of circle. It might appear alien to anyone who does not study modern mathematics, but we have precise reason why each of those elements need to be there, and this is a generalized circle. We anyway, there are reasons why. Okay, metric space, and when we work in quantum mechanics, we have to understand at least metric space and by extension Hilbert space. Okay, now let's move to Kalam. I have 5 minutes. We've read to some extent the Al-Iqtisad fil I'tiqad of Al-Ghazali, and he began this work by presenting us with 3 syllogisms. Okay, this is not unique to Al-Iqtisad fil I'tiqad. It is true also to some other works by Al-Ghazali, that before he began his discussion in Kalam, he establishes 3 syllogisms by which he will simply use these 3. All arguments will follow these 3 syllogisms. So if you don't believe in any of these 3, make sure he will convince you that they are valid. Okay. And after that, we can follow his arguments. Okay. Basically, they are the disjunctive syllogism, or as-sabr wa taqsim, the formal representation in symbolic logic would be like that. When you have P or Q, and then you have not P, therefore you conclude that it's Q. And then the usual modus ponens, or istithna, and reductio argument, which in modern symbolic logic is basically the same structure. Okay, this is one aspect that to me is a milestone that is achieved by Al-Ghazali, where he, because in order for him to refute certain positions of Ibn Sina, he moved from a more material kind of logic to a more formal kind of logic. Although he didn't go all the way to what we understand as symbolic logic, but we can see that the move is from a much more word-based logic to a much more structure-based, form-based logic. So that certain baggages in the philosophical, the truth claims from the tradition of the falasifa can be removed. And there are issues when it comes to moving from the more by applying logic in arguments. And one Professor Wa'il Halak translated this work and wrote a very good introduction where Ibn Taymiyyah criticizes Al-Ghazali, but I won't go into the details. But the point for me bringing this up is that in that criticism, Ibn Taymiyyah is even more, in terms of mathematization, he's even more forward. He brings the logic to its further logical conclusion. If we hold on to some kind of naive realism, then the result will be some kind of very nominalistic worldview. I mean, the logic will become just a play of rules that you don't really arrive at certainty, or if you arrive at certainty, it's a certainty that you have arrived at even before you apply those rulings anyway. So that is what Ibn Taymiyyah was saying. but I would not go further than that. So it becomes a more formalistic and nominalistic idea of logic. Okay, now, so that is one example of the process of mathematization in works of Kalam. The other example, this is a smaller example in Al-Iqtisad fil I'tiqad as well. Imam Ghazali in his proof of the non-pre-eternity of the world, he uses the argument of the revolutions of the orbits of the Sun or Jupiter to show that it is impossible for it to be infinite. He said that he uses the reductio argument. If it is pre-eternal, then what any quantity must be either even or odd. That is a trick that mathematicians use all the time. But if it is odd, then it's one less than an even. So an infinite cannot be one less than even. So it leads to absurdity. So what leads to absurdity must be absurd. So the opposite must be true. In Tahafutul Falasifah, he entertained further that the possibility that those the quantities that are that is infinite may not have the quality of being even or odd, but he rejects the possibility of an actual infinity. So still it is absurd. But of course this can be 1 minute. Okay, this can be discussed further. And then finally, this is the last example that I'm going to discuss today, the discussion of Arad, the Jawhar and Arad. And he gave many examples, so Sukun wal Harakah and the Alwan, etc. And this is an extension. I mean, when we reflect back, what has happened in modern science is that many of those a'rad that previously we considered to be a'rad have, through mathematics, becomes like an essence. Because if we say essence as mahiyah, as what it is, then the color rate, that precise color rate, is the frequency. When Dr. Basil has explained this in some of his talks. So we have a clear definition of an attribute. So here we can also see mathematization as the essentialization of a'rad. So that's all. Thank you.